Good morning, everyone. Welcome to the class of CE 333 Environmental Engineering 2. So, in our last class, in the design example, we did the zoning of the 25-story building. Today, we'll start from here. We'll continue to work on the problem and we'll determine the size of the piping and layout. Okay. So the next step in design is to lay out the piping on drawings. That means uh, draw their location and sizing on drawing. So first of all, you need to design it. So this information is necessary. We may be able to know the pipe length and fitting required. For our purpose, we will use figure 1421, which is a diagram in elevation. So we are referring to referring to this figure. Okay? This figure. We must then assume the pipe length and fittings that will be known when a job is undertaken in the field. So first of all, lay out the pipings in drawing for upfeed zone. For upfeed zone. So we will concentrate first in the upfeed zone here, zone 1, which we are denoting as upfeed zone, and which is approximately 60 feet above the floor and around 70 feet from the main. Around 70 feet from the main. The actual pipe sizing can be accomplished quite simply and efficiently by arranging our calculation in a tabular form, like this. This. The sizing of the upfeed zone will be done first. That's why you're doing the upfeed zone. To use the sizing graphs, figure 1418 and figure 1419, we must determine the permissible frictional drop per 100 feet. Look at these figures, figure 1418 and figure 1419. Figure 1418 and figure 1419. This figure and this figure are important to determine the pipe size. And to determine the pipe size, look at this. To determine the pipe size, diameter, okay? Which pipe size you need. To determine this, what do you need to know, guys? You need to know the flow rate. That means Q, and you need to know the pressure drop. You need to know the pressure drop per 100 feet of pipe. Hmm. Pressure drop per 100 feet of pipe. Now the thing is, pressure drop per 100 feet of pipe, that actually depends the layout of the pipe. Okay, so If friction offered to flow is low enough for water to reach the top fixture in adequate quantity and pressure, all other fixture will receive sufficient water. As I told you, we must determine the permissible frictional drop per 100 feet to use that figure and calculate what pipe size. Now, if friction offered to flow is low enough for water to reach the top fixture in adequate quantity and pressure, all other fixture will receive sufficient water. What does that mean? That means what is your top fixture here in this upfeed zone? Upfeed zone. What is your top fixture? This is the top fixture. I think this one. This is the top fixture. Now, if the fixture pressure, minimum fixture pressure is satisfied here, then all other floors will be satisfied with the minimum fixture pressure. Why? Because as you know, for upfield zone, the pressure decreases as we go upward. Highest pressure is here, and as we go or move upward, the pressure decreases. Now, if minimum pressure is met here, then of course all other floors will meet the minimum pressure because the pressure is the minimum here. Again, in upfeed zone, for example, we have 100 psi pressure here, or how much? 50 psi here, for example. As we move forward, then it might be reduced to 10 psi. This is hypothetical number, just 10 psi. Here maybe like 40, 30, 20. So what I'm trying to say that if you have your minimum fixture here is 8 and that is satisfied, 10 is greater than 8, then of course minimum fixture pressure 8, 8 all are met in this floor or this floor. Or let's say this is 15. Let's say this is 18. If your minimum fixture here is 18 requirement, this is required fixture pressure is 18. So you have, sorry, 15. The minimum fixture pressure required is 18, 15. Then of course you have met the required requirement. Similarly here your requirement is 15, so this is met. Similarly your requirement here is 15, so you have met. Here it is 15. So all remaining pressure, that is available pressure, is larger than required. So all are okay. So if the top floor is met, then all other floors will also be met. So if I go here, is it clear, guys?
Yes, sir.
Now, first, let us find the total pressure available for overcoming friction to flow in pipings and fittings. It will be the main pressure less the sum of the water meter pressure drop, static head loss, meter pressure drop, static head loss, minimum fixture pressure. So how? Where is our formula? Our formula is this. For upfeed zone, we have this. Input equals to output. Now let's look at this. Our input is what? Our input here is the pressure coming from the main, and that is 50. So you put 50 here. We don't have any other gain or pump here, so this is 0. Okay. Now, what is your minimum uh, fixture pressure? F. P is the frictional loss actually. Frictional loss. F is a small p per 100 feet. It is a total frictional loss. 0.434 into h. You know the height. What is the height, guys? Now 60 feet. Let's say this is 60 feet. Plus, what is your minimum fixture pressure? 15. Plus, let's assume the other losses here is representing the loss due to the water flow through the bends, these bends, and these types of fittings. And this is actually, let's assume this is 1. So you should put here 1. So from this equation, you can calculate small p and tell me the value, please. Tell me the value, please. Hello? Everyone, please bring out your calculator and tell me the value, please.
Sir, 41.8 minus
41
41.8.
minus 41.8. Are you sure? Uh,
So 1.30, sir.
okay, okay. I need to add something here. Do you remember that here we, when we determine the upfeed zone height, then what we did is this. We assume that 5 psi drop in piping plus 3.5 psi drop occurs at 4 meter, right? 3.5. So we have to add this here in the other losses. In the other losses, we have to add this here. Okay? So this is other loss.
Yes, sir.
Now tell me the value, please.
Sir, 4.46.
So 4.46, this is the total frictional loss. Total frictional loss. 4.46. Now this pressure of 4.46 psi frictional, this frictional loss can be utilized to overcome friction caused by flow through pipings and fittings. We evaluate fitting friction by stating the length of the straight pipe of the same size, which will offer equal pressure drop at the same rate of flow. Table 14.4 lists equivalent pipe lengths for several fittings and valves of various sizes. So go to the table 14.4 here. This actually tells you allowance in equivalent feet of pipe for frictional loss in valves and threaded fittings. Allowable allowance in equivalent feet. So these are all in feet. What does that mean? That means that, for example, um, in valves and threaded fittings. For example, we have an elbow, 90-degree elbow. Let me show you the examples. For example, this is an elbow. This is a T junction, right? This is coupling. Did you see? And this is gate valve. So in these fittings, whenever the water tries to flow, due to this undulation, there will be frictional loss. Hmm. There will be frictional loss. Here there will be loss. Here there will be loss. Okay. So frictional loss in valves and threaded fittings. Frictional loss in valves and threaded fittings. Valves and threaded fittings means this. So if you, let's say you have a fitting here, or a valve here. So due to this valve, there will be some frictional loss, pressure loss. P1. And this length is, for example, 10 feet. Now, if there is no fitting such this, hmm, like this, then for the same length of pipe, 10 feet, the frictional loss will be smaller, right? For example,
Yes,
frictional
sir.
loss here is 2 in total pipe. In this overall pipe, frictional loss is 2. Here, frictional loss is 1.5. Why? Because it doesn't have any fittings. Now, if we increase the length, for example, 3 feet, then total it becomes 13 feet. Then P will increase, right? Let's say for this 3 feet increase, this will be 13 feet now. For this 3 feet increase, P has increased to zero point 0.5 again. So it has become 2 feet, sorry, 2 psi pressure drop again. 2 psi pressure drop again. That means this 3 feet length of the pipe is equivalent to the pressure drop in this fitting. Let's say this is 0.5 psi. Here also the pressure drop is 0.5 psi. So together it becomes 13. So instead of 10 feet, this pipe is equivalent to this pipe. So 3 feet is the equivalent length for this fitting. Did I make it clear?
Yes, sir.
So that's why look, for different diameter of piping and fittings, if it's a 90-degree elbow and with this inchy 3 by 8 inchy, then pipe length should be equivalent pipe length is 1 feet. That means the frictional loss in a 90-degree standard elbow of 3 by 8 inch is equal to the frictional loss in 1 feet pipe. Clear?
Yes, sir.
Similarly, if you have a 3 by 8 inch gate valve, then the frictional loss will be then for example the frictional loss is let's say zero point 0.1. Now if you let the water pass through a zero point 0.2 feet pipe, then exactly the frictional loss will be again zero point 0.1. So this is equivalent length, PSI. So that's what they are telling here, that where here table 14.4 lists the equivalent pipe length for several fittings and valves of various sizes. Now, at the moment, we do not know the pipe and fitting sizes. Do we know this diameter? No, because we do not know the pipe sizing yet. Therefore, an estimate of equivalent length must be made. The riser is a straight vertical run. The riser is a straight vertical run. That means this pipe is the riser. Okay, we can denote it as a riser. So the riser is a straight vertical run, and low increase in actual length to allow for fitting is reasonable. If the measured length of pipe from main to foot of riser is 70 feet and the riser is 60 feet, then the total actual length is 130 feet. What does that mean? That means this is your zone 1. Okay, this is 60 feet and this is 70 feet, right? The total length of the pipe is what? 60 plus, guys. Total length of the pipe is what? From here all the way up to there, up to
60
this.
plus 70, sir.
Remember, here pressure here is 50 psi. So from here all the way, from here all the way up to there, what is the total length? 60 plus 70. That is 130 feet. So that is 130 feet. Now, since we do not know the pipe size still, since we do not know the pipe size yet, therefore, we will make provision for the fitting losses by virtually increasing the pipe length, virtually. And we will add 50% of you will add 50%. Just the same way we have done it here. We increase the length a little bit so that we can accommodate the frictional loss in the fitting. Here, for example, we will assume 50% increase in length. That means your 130 feet will be multiplied by 130 into 0.5. 50% increase. Here this 130 feet will be increased by 50%. So 130 plus 50%, 130. That means 1.5 into 130. Clear?
Yes, sir.
So that is 130 feet. Sorry, 195 feet. Now, how much pressure we have available for frictional loss? 4.46 psi. So, for 195 feet, you have pressure available to drop 4.46 psi. For 1 feet, this is 4.46 divided by 195. For 100 feet, you have 4.46 divided by 195 into 100, which is 2.3 psi per 100 feet. 2.3 psi per 100 feet. Now, we can use figure 1419 to calculate the pipe sizing. We need to make this table. Okay. So let's see. We are doing for the upfeed zone, which is actually 1, 2, 3, 4, 5. Okay. And in each floor, how many fixture units do you have? Let's see. In each floor, how many fixture units do you have? Except 24 and 25th floor, all other floors have, for 3 water closets, one water closet needs 10 fixture unit. So 3 water closet needs 3 into 10, 30 fixture unit. Or this. This is also similar. Okay. This is also similar. One water closet needs 10 and one urinal needs 10. So 2 into 10, 30. One lavatory needs 2 fixture unit. So 2 lavatories need 2 fixture unit. So together this is 2 into 2, this is 4. So together 34 fixture unit in each floor. But in 24 and 25th floor, remember, we have used flush tank instead of flush valve. And flush tank required less fixture unit. So here, the fixture unit requirement is 5 fixture unit for 1 water closet. For 3 water closet, this is 3 into 5, 15. So this was flush valve, this is flush tank. And 2 lavatory, this is the similar 4, so it becomes 19. So we are doing, so total load on the service pipe is 23 stories, has 34 fixture unit, and 24 and 25th, that means 2 floors have 19 fixture unit. So 2 into 19, together 820 fixture unit. Clear?
Yes, sir.
Now each floor requirement is 34 fixture unit except these two. Let's make this table. So service pipe 1 requirement is 34. Service pipe 1 means what? I mean, that means this floor 1. So service pipe 1 needs 34, right? No. How much demand is there, guys? Remember, this need what? 34. This needs what? 34. This needs what? 34. This needs what? 34. This needs 34. Now, all of this demand will flow through this pipe. Am I right? Huh? All of this demand will flow through this pipe. Am I right?
Yes, sir.
जी
Okay.
सर.
Yes, sir.
So, what is the total requirement? 34. 1, 1, 2, 3, 4, 5. 5 into 34. Am I right? Hmm?
Yes, sir.
And that is 170. Now let's look at the second floor. Once you have fulfilled the demand here, once you are here now in the service pipe 2, how much you need, guys? 1, 2, 3, 4. Am I right?
Yes, sir. 136.
So 4 into 34. Then once you are here, then what will be your demand? 1, 2, 3. 3 into 34. So 3 into 34. Here 1, 2, 3, 4. So 4 into 34. Here 1, 2, 3, 4, 5. So 5 into 34. So that's how you do this. 170, 136. This is 5 into 34. 5 into 34. This is 4 into 34. This is 3 into 34. This is 2 into 34. And this is 1 into 34. Now, here 178. By the way, where did you get the 820 from? Where did you get the 820 from? Total load is 820. That's why. Total load is 820. That's why. Okay. So look at this. For zone 1, you are lifting the water through this pipe. Hmm. For zone 2, this. For zone 3, for example, for zone 3, you are lifting the water through this pipe. Okay. And then for zone 2, you are using this pipe. Okay. For zone 2, you are using this pipe, use it through this tank. Through this tank. And that's it. So where were we? We were here. So for 170 fixture unit, what is your flow? Go to the figure here, or these two figures are same. This is just the zoom in of this figure. So let's look at this 170. For 170, I'm sorry, this is 40, 50, 60, 70. 170 is here. What are you using? In the zone 1, flush valve. So you have to use number 1, this one. So 170. So what's the demand, guys? Around 82 or something. Am I right? For 170 fixture unit, what is your demand, guys? 82 or something. Am I right?
Yes, sir.
Yes, sir.
So 82. Or 85. So you know the demand now. Now pipe size. How do you determine the pipe size, guys? Now it's easy. First of all, you know the to know the pipe size, you need to know two things. One is Q, which is here. You know this is 85. Another is pressure drop per 100 feet. Pressure drop per 100 feet, which you have already calculated from here, 2.3 psi. So this is what Q, 85 and 2.3. So 85 and 2.3. Let's go back to the figure 49. 85 approximately here. 85 and what? 2.3, right? Pressure drop is what? 2.3. Are you following me? Are you
Yes,
Yes,
following
sir.
me?
sir.
Let
Yes,
me
sir.
know if you don't get anything. So 2.3. So this is approximately diameter is where? Approximately this is 2 and this is 3, right? So 2.5 inch approximately. Approximately 2.5 inch. If I show it more clearly, this is your point. This is 4 inch pipe. This is 3 inch pipe. This is 2 inch pipe. 4 inch, 3 inch, 2 inch. So you are here. That means you are in between 3 and 2. This is 2 2.5. This is 2. This is 3. So this is 2.5. So approximately 2.5 inch. Approximately 2.5 inch. They took 3 inch. That's okay. Still that's okay because we will check this again. The reason is they have increased it to this level. That means here. Okay, so you could take 2.5 or 3, but don't take the smaller one. 2.5 and 3. Okay, similarly you do this for other pipes. 77 again, this is 2.3. 68 2.3. 58 2.3. 43 2.3. Clear? And from there you'll calculate the pipe sizing. Clear?
Yes, sir.
Here this is 184 and 2.3. This will be 3.5. Now you know the sizing of the pipe. For example, from the analysis we can say that for zone 1, for this zone 1, you need one gate valve, 3.5 inch, 4 coupling, 3.5 inch, 90-degree elbow, ELLS, that means elbows, 3.5 inch, 90-degree elbows, again 3 inch, and 4 T's. T's means these T's, 2.5 inch. If you know this, then from this figure, where did you know this inches now? Because now you know this. So once you know this, then you can go back to this table and find out the equivalent length. For example, one gate valve, that is 3.5 inch. So one gate valve, where is gate valve? Here, 3.5 inch. That means in between 2 and 2.7. Let's say this is 2.5. So 2.4 or 2.5. So feet. Is it clear?
Yes, sir.
So 4 couplings, 3.5 inch. Whatever you will get, you have to multiply it with 4 because you have number 4. I mean, you have 4 couplings here. So total, you have got 82.5. Sorry, 82.8. This is for frictional loss in the fittings. Now, remember, this was our actual pipe length, and we have increased this pipe length equivalent length 50% of actual length to accommodate what? To accommodate the fittings loss in the fittings, right? Loss in the fittings. What is the value, guys? Tell me. What is the value, guys? Tell me. Hello? What is the value? Are you there? Hasibul Islam.
Yes, sir.
What is the value? Can you please tell me?
So 195.
No, no, no. Only this portion.
Oh,
65.
sorry, sir.
65, sir.
65. So this is available for fitting loss. Now actually from the fittings, how much length you need? 82.5, 82.8. That means whatever we have provided 65, which is less than the actual. So this is not enough, not quite enough. So we could correct our drop by boosting the equivalent to say 85 feet. So instead of giving 65 feet here, you could redo the calculation by 130 plus 82.8, or let's say 85. So in that case, this 195 will be 130 plus 85. Am I right? Right?
जी सर.
Yes, sir.
So we could correct or redo our drop by boosting the equivalent length to 85. Then we may check the pipe sizes in our table again. In this instance, little or no change would result because the difference is not that much. So, but from experience, we can tell here that this would not make much difference. So we keep this here. But in reality, what you could do, you could redo your equivalent length 130 plus 85 and then put this here. Then you got this 2 point, instead of 2.3 you will get 2.2, or let's say 2. So you do the pipe sizing again and recheck here at whether this is equal to or close to this. Okay. So we are done with our pipe sizing in the upfeed zone. Now we will determine the pipe sizing in the downfeed zone. Same basic or same principle we will follow. What do we need to determine the pipe sizing? We will use figure 1419, figure 1419, and to use figure 1419 you need two things. One is discharge or demand, and the another one is what? You tell me. Huh? Another thing is what? Frictional loss per 100 feet length of pipe, right? Loss of pressure per 100 feet length of pipe. So you go to figure 1419, you have Q here, you have pipe sizing here, sorry, you have pressure drop per 100 feet here. If you know these two, you'll be able to determine the pipe sizing. Clear?
जी सर.
Yes, sir.
That's what we have done here actually. Okay, so we determine the pipe sizing for different Q, and P by 100 is fixed, for example, and size. You determine the size, and once you determine the size, you can calculate the fitting losses and check it with the actual, check with the assumed equivalent length. That's it. So whatever we have done is to calculate pipe sizing, you need to use figure 1419. And to use figure 1419, you need to know what? You need to know Q, and you need to know pressure drop per 100 feet length of pipe. So you calculate Q, demand in each floor, and you know this. So you use this figure and you calculate the pipe sizing for different demand. How did you calculate this pressure drop? From the formula, from this formula. I'm just repeating again. From this formula, you determine how much pressure you have available to drop due to friction. So small p. You calculate this from this formula. Once you determine this, what do you need to know? You need to know per 100 feet, right? So this pressure drop happens for what length? What do you do? We calculate the total length of the pipe and we increase this length 50% to accommodate the frictional loss, which we call it equivalent length. So 1.5 into L. So that means 1.5 into L length. Your pressure drop is small p, is this, which you have calculated from the formula. So for 100 feet length, your 1.5 into L. Here is P. Did I make it clear?
Yes, sir.
Yes, sir.
So I'm summarizing this so that you can visualize it better now. Determine the pipe size, you need Q, and this you estimate Q from the fixture units, and you estimate this by this method. First of all, you calculate P from this formula, and then to calculate this in per unit length, that means per 100 feet. First of all, you increase your available length of the pipe 50% or 60%, and then from there you calculate pressure drop per 100 feet length. That's it. Now once you determine these pipe sizes, then you should give a check whether the equivalent length due to fittings is equal to the 50% length. If not, then you may need to increase or decrease a little bit of this equivalent length here. That's it. Any question? Any question, guys?
No, sir.
Now, same basic, same principle. Let's determine the pipe sizings for downfield zone. Let's start with the zone 3. That means this zone. If you look at zone 3, what's happening? At the topmost floor, you have 25th floor. Okay. And this is your overhead water tank. And we determine this height, minimum tank height. This is 24 feet. This is 24th floor, 23rd, 22nd, and 21st. For downfeed zone, this is downfeed zone, by the way. For downfeed zone, the formula was what? Remember the formula for downfeed zone? This. This was for the upfeed zone. And for the downfeed zone, the formula should be this. Input equals to output. Always input equals to output. So from here, your input is, from the potential energy from the height difference. So that's why 0.434 H A into H is your input plus minimum fixture pressure plus different types of losses. So if you go back to there, at this 25th floor, if you apply this, that point here basically 0.434 into H plus other gain equals to minimum fixture pressure plus loss, different types of losses. So 0.434 into H. What is the H here, guys? Vertical height difference from the water tank. 24 feet, am I right? Am I right?
Sir, একটু আবার sir.
From here to there, what is the height difference? 24 feet, right?
Yes, sir.
So H is 24. Put 24 here. You don't have any other gain, so this is 0. What is your minimum fixture pressure here, guys? You're using what? Flush tank or flush valve here? Tell me.
Flush tank.
Flush tank. For flush tank, minimum fixture pressure is 8. That's why you have put 8 here. F is 8. Assume in the branches, elbow, and these things, your loss is 1 psi. So you have put 1 here. And your other losses and loss to these things are basically P. P is what, guys? Pressure loss per total frictional loss, basically. This is total frictional loss. Total frictional loss. As the water passes through the pipe, there is frictional loss, and that is P. This is same as this P, what we have done. P, this P. Total frictional loss. So from here, you calculate small p as what? 1.4. This is exactly similar to the way you have calculated P in the upfeed zone by the formula. Similarly, in the downfeed zone, we are estimating the small p from the formula. Why? Again, because you are determining the pipe size. To determine the pipe size from figure 1419, you need Q and you need this. So you are determining this. So P equals to 1.4 psi. For 23rd floor, 23rd floor, here. Okay, let's come back to 23rd floor later. First, look at this table, table 14.6. Just the way we made a table for upfeed zone to determine the pipe size. We are also making a table for downfeed zone 3 to determine the pipe size. So in 25th floor, we already determined the fixture unit in each floor. For 24 and 25th floor, the fixture unit is 19. And for other floors, the fixture unit is 34. So for 24 and 25th, this is 19. And for other floor, this is 34. Another thing to notice here that the water is flowing from up to downward. So the fixture unit here at this pipe is equals to the fixture unit, it the accumulative of the fixture unit of all the bottom floors. Am I right? Of zone 3, right? Right?
Yes, sir.
So look at this. At 25th floor, your accumulated fixture unit, zone 3 is from 16th to 25th floor. So accumulated fixture unit in 25th floor will be 1, 2, 3, 4, 5, 6, 7, 8. So 8 into 34 plus 2 into 19. That is 310 fixture unit. In 24th floor, what would be that? 310 minus 19. That is 291. In 23rd floor, it will be 291 minus 34. That is 272. 291 minus 34. This is 272. 310 minus 19 equals to 291. 272 minus 34 equals to 238. Is it clear?
Yes, sir.
So from and the demand flow, similar, go back to the previous figure. Let's say for 310 fixture unit, what is your Q? This is your Q, by the way. Demand flow. 310. For 310, let's say 10, right? So this is around 250. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each is 50. So this is 300, 310, right? 310. So you are using flash tank. So approximately this is 310. 310. And here 310 is approximately here. So this is, and majority is for flash valve, by the way. Majority of them is flash valve. So you'll take flash valve and this is approximately 110. 110. 110 GPM, gallon per minute. These are in gallon per minute. Fine. actual pipe length. What is the actual pipe length, guys, here? The actual pipe length, vertical 24, horizontal. This is the pipe, by the way. This is the pipe. This is the pipe. So vertical 24 and horizontal 10 feet. Horizontal 10, vertical 24. What is the total length, guys? 24 plus 10. What is the total length? So 34. Clear? Clear.
Yes, sir.
Yes, sir.
So 24 vertical and 10 extra for horizontal. Now, similar to the previous case, we will increase the length by adding the equivalent length to accommodate the frictional loss in the fittings and pipe, basically fittings and valves. So we will increase it to 50% again. So 34 into 0.5, that is 17, right? This is 17. So total length will be 34 plus 17. 34 plus 17, which is 51. 34 plus 17, or you can write 34 into 1.5. Whatever you approach you take, you will get 51. So to calculate the pipe sizing, you need two things. One is Q, another is this. So you know the Q here. What is Q, guys, here? GPM flow 110. Now what is your this? Okay, let's look at this. For 25th floor, you calculated a small p as 1.4. Total frictional loss. Now this loss is happening for what length, guys? 51 feet length. For 51 feet length. So for 51 feet length, your pressure drop is 1.4. So for 100 feet length, your pressure drop is 1.4 divided by 51 into 100. Tell me the value, please. Tell me the value, please.
So 2.7.
2.74.
2.74 or whatever it is, 2.8 or 2.74. So approximately this is 2.8. Pressure drop per 100 feet. Pressure drop psi per 100 feet, 2.8. So now you know everything. You know Q and you know pressure drop psi per 100 feet. So 110 and 2.8. Let's go back to the figure. 110 and 2.8. Here. 110 and 2.8, like here. So approximately 3 inch, right? This point, right? 3 inch. Am I right? Huh?
Ji sir.
So 3 inch. Now for the 23rd floor, look at 23rd floor. What is your available pressure, guys, here at this point? 25th floor. What is your available pressure? Your available pressure here is requirement was 8, and we provided +1 for pressure drop provision in the branches. So here we have only 9 psi available. We have 9 psi available here.
Yes,
From
sir.
there to there, if you go to 23rd floor here, what would be your gain? Look at this. Your target is here. You can start from here. You can start from overhead water tank, or you can start from here. This method is easier because you have already estimated the frictional loss and other things. So this is easier. So let's go with this approach. Here you have available 9 psi, 8 plus 1. So you have other gain 9. Plus for this height difference, 20 feet, you'll get 0.434 into 20. Am I right? Hmm? Is it okay?
Yes, sir.
Okay. Equals to, remember we are using flush valve here. So what is your minimum fixture pressure? 15. Again, plus, let's take +1 for the pressure drop in the branch. Plus 1 plus other losses. Let's say other losses are small p again. So from this formula, you calculate total frictional loss. This is basically this. Please tell me the value from here. Tell me the value from here, please. Point 0.434 into 20 plus 9. This is 0.434 into 20 plus 9 equals 15 plus 1 plus small p. Tell me the value, please. Everyone, please, not just
1.105.
one or two. Everyone, just check it, everyone. What is that, guys?
1.105.
Everyone, want everyone to calculate this. 1.105. Fine. And we are at 23rd floor. We're at 23rd floor. So at 23rd floor, this is our fixture unit, and from figure we can calculate the Q. Okay. And your pipe length, actual pipe length here is 10 feet. I mean, from 24 to 25 feet, this is 10 feet, that's okay. And we will increase it to 5 feet, that is 15 feet. That's fine. How much did we get here? 1.105. So this is where did you calculate this? Here. Did everyone get this value? Did everyone get this value?
So 1.68.
So 1.68 আসে স্যার।
So this is 1.68. Now, here, what is the length of the pipe? Since you have started from here, remember, since you have started from here, what is your length of the pipe here? 20 feet, right? So for 20 feet length, your frictional loss is 1.68. For 100 feet length, your frictional loss is 1.68 divided by 20 into 100. Tell me the value.
8.4.
Everyone. 8.4.
8.4 স্যার।
8.4, sir. 8.4, sir.
So here, oh, there's a mistake I've done. Here 20, right? 20 feet length, but you have to increase it to 50%. So instead of 20, we will use 1.5 into 20. So this is, now tell me the value. Now tell me the value. 5.6, am I right?
Yes sir, 5.6.
So this is 5.6 psi per 100 feet. And where is this happening? 23rd floor. So 5.6. 5.6. Since 24th floor is in between this and this, so you can just assume this is also 5.6. Or you can just calculate the value, no problem. Okay, like you are here, if you are here at this point, then you can use this formula to calculate a small p again. Let's see, here you have 9 available. For 24th floor, how much you have available? Again, you have 9 available, but you want to come from there to there. So how much you will achieve? 10 feet. So 0.434 into 10 plus other gain, that is 9, equals to fixture pressure here is 15 plus 1 plus small p. What would be the value, guys? The value would be 0.434 into 10 plus 9 minus 16. So this will be what? Tell me the value. You'll get an interesting value. Tell me the value, please. Oh,
minus
by
4.33.
the way, by the way, here this is 24th floor, right? So this is not 15. This is 9. This is 8 plus 1. Am I right? Because this is flush valve. Sorry, flush tank. So 8 plus 1. What's the value, guys?
4.34.
4.34. And this is 10 feet length, so you will increase it to 1.5 and 50%. So 1.5. For this length, your pressure drop is 4.34 psi. For 100 feet length, your pressure drop will be 4.34 divided by 10 into 1.5 into 100. What is the value from here?
So
28.93.
28.93.
28.93. Uh, for 4.34, we calculate it, and this is 10 feet length. We have to increase it to 15%. So we have the other gain and 8 plus 1. Fine. So this is actually, you can see 28.93. So this is very high pressure, but since in that's why we didn't calculate this. Since this is in between 25th floor and 23rd floor, so pressure drop, whatever we get this from here, we can safely put it here because this is in between. What I meant is, if this is like um, 2, 3, 4, then here it will be between 2.2 and 3, that means 2.5 or 2.3. Similarly, this will be in between 3 and 4. Okay, so we didn't put it here to make it uniform past 3 floors. To make it uniform, we have made 2.8, 5.6 and 5.6. Now for all other the rest of the floors, let's see 22nd floor here. What will be the value, guys? For 22nd floor, you'll start from here. Second floor, you'll start from here. And in the 23rd floor, you had flush tank. So this is 15 plus 1, right? So 0.434 into 10, because this is your length, height, plus 16. Why 16? Because whatever you have available, 16 psi. So this is 16. Equals to, what is the demand here, guys? 15 plus 1 for branch plus P. So from here, you'll see that P is 4.43. Okay, 4.34. 4.34. And similarly, for 100 feet, you will get 4.34. This is for how much length? 10 feet. So 10 into 1.5. For 100, this will be 4.34 divided by 10 into 1.5 into 100. And what the value we got, guys? 28 point, huh?
93.
93. So 28.93. So similarly, for all other floors, you will get 28.93, 28.93, and 28.93. And using this Q and this pressure drop per 100 feet, from using figure 1419, you can calculate the pipe, you can determine the pipe sizes. Clear?
Yes, sir.
Any question? No question. Okay, then thank you very much. Have a good one and stay safe.